The weird thing about Myst is that in my memory it looked much more realistic and immersive than it was. The VR version will break your brain, and in a few decades we'll look back and think it looked janky. Yeah. QuickTime was available on Windows at the time as well. Was it already? Remember, this is a 93. Like at the start, I remember QuickTime being Macintosh only. Maybe I misremember, but I thought it was that. You know, it was first Mac exclusive. It was available in 3.1. Okay. I didn't know that. Cool. Yeah. By the way, Ada, regarding what you said about how much more realistic and immersive Myst seemed, I think I've had a similar experience. Like, first, I didn't quite remember as much all the dithering that was going on. But remember, back then we were using cathode ray tube displays, you know, like, so they were a lot fuzzier. I mean, the Mac screens were pretty crisp, but it probably softened it. Like right now on TFTs, all this dithering will probably look weirder. Although on the other hand, for you out there, it's gone through JPEG compression, so it'll probably look a bit fuzzy and smoothed as well. It looks pretty good, like for me here, but you can tell the dithering, and of course pixels were bigger. Like, I'm playing this on a 4K display, which has, I think, even in 1x resolution, it probably has close to, I don't know, 100 DPI or something. And you know, Macs back then were 72 DPI. So that's not quite half, but, you know, a third or something lower. And so all the pixels are a lot bigger as well, and so it filled out your field of view much better. But, you know, looking at this, yeah, we had black borders around what Myst displayed on our 640 by 480 display. And, you know, so even if it looked larger, it's, you know, it's just, you know, it's still, it was never full screen. And I don't remember that at all, that it was like a smaller box. What I do remember is that the movies stood out. Like, this one here. So if we click this. Oh, okay, something with the movie playback is iffy at the moment here in the emulation. But like, you see this, you can kind of tell like the rectangle where the movie was and things like that. That's basically what I meant. Yeah. When I was your age, we had CRT and pixels were bigger. It sounds a bit old man, yeah. When I was your age, we had to carry our CRTs up the hill, both ways, barefoot, in the snow. Something like that, yeah. Tony says, Myst requires QuickTime 2 or higher from the PC version specs. Okay, cool, yeah. I mean, it makes sense. Remember there was this big, like, lawsuit where it came out that apparently video for Windows, they had basically, I think, reverse engineered QuickTime and just used that information to create it for Windows. Which is why, we have Windows Media Player today, because they needed to do a clean room re-implementation to get that removed from their record. Ironically, the DOS pixels were even bigger than Mac pixels. CGA, EGA, MCGA, VGA 320 by 200 versus Mac VGA 640 by 480. Yeah. Yeah. I mean, at that time. But I think, you could get PCs that would do 640 by 480. But yeah, it wasn't as common yet. Yeah, you're right. Does EGA could do higher resolution? Same with VGA though, right? 220. Yeah, that's what I kind of remember. That you could get 640 by 480, but on most machines it wasn't that big a thing. I'm just trying to remember. There was something I just thought of. That I should mention, and I don't remember it anymore. I think it was something I mentioned on Twitter as well. But, EGA was 640 by 350, by the way. It's not quite 480, yeah. Anyway, so yeah, looking forward to the new Myst. And they rewrote it. I think it was in the context of how one would rewrite it. I guess I should show. Well, oh, I ejected the Myst hard disk, so I would have to restart at the least. But basically, Macs kept that 72 dpi through until early 1990s. So if you print something from the Mac Plus screen on an image writer, the pixel image would be exactly the same size on paper as on the screen. Yeah. It was, I think there were a few outliers, but in general, they were all 72 dpi exactly. Whereas on PCs, I think nominally, was it 75 dpi or something, I think, is what Windows used for everything. So it's just slightly different, just like the gamma was slightly different. At the time, yeah. But in like the later Macs, I think the Color Classic, I think, was the first one which had still the same 640 by 384 as the original 12-inch color display, but had it on a 10-inch CRT, and so had more like, I don't know if it was 80 dpi or whatever, however that scales down, or it was just 75, or I don't know what it was, but like had smaller pixels all of a sudden, which made some things a little harder to deal with. I mean, we've had the same things with the iPads, where it was like, oh yeah, your touch targets should be 40 by 40, and some people on the original iPad went like, 40 by 40 is a little big, I'll just, use less. And then the iPad 2 came out with smaller pixels, or not the 2, I think the iPad Air or Mini or whatever the first small one was, which had basically the same resolution, just on a smaller display. I think Color Classic still tried to stay as close to 722 DPI as possible. One reason for the small... Well, but as I said, the 12-inch screen was 512 by 384. The 13-inch screen was the 640 by 480 color screen. And the 12-inch black and white screen was 640 by 482. I guess there it kind of happened with the black margins. But yeah, something like that. Yeah, I don't know. Like, I just remember that at some point realizing that some of the Macs had started having smaller pixels. But yeah, that was since desktop publishing was a big thing on the Mac. That was what they went for. But with the multiple scan type monitors, it all changes. So can have 640 by 480 and 1024 768 on the same 15-inch monitor. Yeah, exactly. Those were, I guess those were where they finally gave up and said, okay, we can't pre-configure this to be 72 DPI exactly. Yeah, but you know, it's all I'm saying here is from memory. Talking a lot here today. Oh yeah, I guess I wanted to show how a Myst did the whole, how do I save how do I set up the state? Let's see. We had this one, for example, should be setting up some state. Probably in the card script on open card. Yeah, so you see, like, it's fairly standard code for a programming language that doesn't save everything you do like HyperCard. So they have my, we know now, is the prefix for the Myst age, gear gate, and gear setup. Put false into gear setup. Set cursor to none. So that means hide the cursor. If my gear gate is open, if Myst gear, I always read this as my. If Myst gear gate is open, then gear music. So I guess it was like ratatatatat or something like that. If the last word of field picked name is not gate open, then put gate open after field picked name. Okay. Wait 0 is a weird thing. I don't know if that was wait 10 and someone then said, oh, let's put it to 0. The last word of picked name, okay. On idle, okay. That's one of the things they did a little weirdly. Like, a lot of things here happens in idle handlers. So they check if gear setup is not true. So only then this idle runs. Oh, I think it was because open card gets called as soon as you jump here. And remember, the save game goes to whatever card was last open and triggers an open card message at that point. And I guess they wanted the open card code to run, so they didn't do the lock messages trick I did to prevent the message from sending at all. And then idle is periodically called, you know, when, you know, like just when the card is open, it periodically sends an idle message. Like you can see that here. Message box. Show message watcher. It's not set to idle. Okay, so if I do the browse tool, yeah. You see here, it does idle and then shows you all the messages. The problem is that these handlers don't run through, but you see it periodically calls idle. It would be more impressive if my idle message wasn't failing here, because I've just loaded the stack without all the Myst things around it in this moment. And now here, see, they do precure sound idle, so they run, if it's open, then show an open animation, otherwise show close animation, pre-wait. So I don't know what these handlers do. Pre-wait. If there's not a window, clock one left chain movie. So if that movie doesn't exist, create the movie in initial state. And then, but invisibly. Okay, and then if we have a window, don't erase. Oh, that's what prevents the flashing. That's why I thought. Okay, that makes sense. Set the cursor, I don't know, so they set up the movie here, and if it's open, then set the current time to the end time. So basically they play the movie forward or backward depending on what you do. That's also very efficient. But you see, like, that's how they do it. There are no, they didn't create buttons with icon animations or something like that. They just created, they just place those movies there, and there is equivalent code on in a regular C application like you would write for Windows. So that's why I think it would port fairly easily. You still remember how Performer 5260? Oh, that's the 15-inch all-in-one power PC. I had a 5300. That was kind of my, I think it's still the my favorite Mac of the older ones, at least of the Power PC era. I guess I also had a G4. That was also a really nice machine, but like of the old gray ones, probably the favorite one I ever owned. Is limited to fixed by specs to 640 by 480 resolution, but you were able to accidentally get it to show temporarily 832 by 624 because of a bug loophole in system software. Oh, ooh, cheesy, cheeky. Yeah, I had the 5300, and that had, I'm pretty sure it was 832 624 out of the box, but I think you could turn it down if needed. That might have been another reason why I might not have noticed that Myst had a black box. If they switched it to 640 by 480, then the black box would have been a lot smaller. You recall on System 753 you used the monitor's control panel from System 6 or 7, and it allowed switching it until next reboot. Ha! That's okay, that's cheeky. Yeah, that's if Apple does stuff like that. Okay, and now I remember the one thing I still wanted to show you, and that is one thing is weird. So all these external commands that let you add color to HyperCard usually do graphics by doing picked resources. So those recorded drawing commands. So you would expect this Myst stack to contain only picts. And remember, Myst is color only. You can't play Myst in black and white. When it starts up, it tells you, hey, I need 256 colors, and since this emulator runs in thousands of colors, it will actually switch my colors down to be able to do palette information. So this is how you expect all of that to look. Like, there will be these little pictures, and those will be shown in the various spots. Right? That's normal. But then, what is this here? Kicken color icon, and you see some of these are the piano keyboard buttons, and these are those switches out in the courtyard. So, why are those color icons? And that surprised me a little. And I think the Myst application itself actually contains a color icon X command. What is it? XC icon 3 here. So that surprised me a little, but not that much, because remember, picked was a bunch of recorded drawing commands. So there was a lot that QuickDraw did when drawing a picked to, prepare for something that might never happen, like a circle being drawn and things like that. So that makes sense. Whereas color icons were made to be drawn really fast and were basically just a pure pixel map. Just the pure pixels. So it makes sense that they, especially for the smaller ones, and I think, what size is these? Icon size? 61 by 29. So that's also something special about color icons, by the way. They could have, I think like they were limited to something like 127 by 127, which means their size was probably stored as a byte. Or maybe it was even 250. No, I don't think it was 255. I guess I can just try. Oh, okay. It doesn't even complain. I thought there was an error message and a limit to color icon size. I don't know, maybe I misremembered. I mean, technically it should go to 32,000. If it's just a bitmap. Maybe it was no color cursor was 16 by 16. I don't know. Anyway, so that makes sense. But now comes the special thing. Do you see this? Those are black and white 32 by 32 pixel icons. And I have no clue why they are in there. Like, is this from like the prototyping stage and they just didn't replace it? I'd be really curious to find out what how those came about to be. Like, if these are just left over from an early prototype, or if those are used as masks in drawing somewhere. I don't know. So that's also curious. And of course here is the color palette for the Myst Island. Which is why it looked so good even with only 8-bit color. So yeah, that's that. Speaking of flashing, one interesting way to prevent a white flash when creating a new window on black screen while wanting it to stay black was that you could set the window background color, with a WCTB resource with this edit as black, so by default the window would open directly with that color without temporarily showing the default white background color. Yeah, you could also do that in code as far as I remember. Like, as far as I remember, if you created a C window record and created it invisible, you could, I think, set the background color and then show it and it would draw. But like there was a separate background color call, if I'm not completely mistaken. I guess we can check. Toolbox Essentials should be the window manager. Introduction Event Manager, Menu Manager. By the way, these are PDFs because I manually exported them. They're based on the original doc viewer files, so don't think people used PDFs back then. Apple had its own PDF-like thing for viewing this documentation. using the window manager reference 464 routines. That should be 474 is where we probably want to be. Okay, that's still chapter 3. Chapter 5, we skipped it. 4, end update. That looks like we're in the right. Begin update. Well, I don't know. Actually, I think it's, you'll believe me, I can look it up some other time on a faster operating system or something. It's really slow in this emulator viewing PDFs. The color icons are interesting as the data is actually almost pure pixmap bitmap data as documented inside MacBooks, so technically they can contain any pixmap data. Also, Kitten resources contain their own color tables, palettes in each of the resource. Yeah, exactly, yeah. I actually wrote a resource editor once, so I actually reverse engineered not reverse engineered, just, use the documentation, but I wrote my own code to load a color icon into RAM and to write it back out. Which is, like, today this is simple, but back then I was a beginning programmer, so this was all complex, was all new to me. It's just a standard thing. Like, a lot of the data structures in classic macOS were basically the same in RAM and on disk. Just that, of course, so a pixmap and a color icon was like one data structure that contained like the size and the pixel format and all that information it needed for drawing, and then a pointer to the color palette and a pointer to the actual pixel data and things like that. And in the case of a color icon resource, all of these sub-pointers were just appended to that first data structure. So you loaded one huge block in memory that contained all of those. But now that you had loaded it, you needed to lock it down and then edit the pointers in the data structure to point to, like 50 bytes down. So you had to take the relative information you had and turn it into actual pointers so that it could actually be drawn. Or I'm not even sure if they just pointed to the relative things or if they just like loaded a copy and referenced that. It could be that loading a color icon involved building the whole data structure kind of quote unquote three-dimensionally from the flattened information and then closing the color icon again. And all other resources usually were just, you use the resource itself as the data structure. Like, what do we want to look at? Let's look at our HyperCard standalone with ResEdit. And so, for example, the dialog item list, which is where all the controls in a window are defined. If you open that, that's how it looks. You have these different boxes. But you can also open it how it really looks inside using the template. So that's how that resource looks. And so these items are all the same. It has a rectangle, it has a type, and it has some extra info, which is a string for all of them, I think. And some just don't. Oh no, here, for example, some items just have some bytes in there. I should probably look at the template to know exactly. Where is... I don't have ResEdit itself yet. I've been, like, the standard files that everyone would have. In their open special menu in ResEdit would of course be ResEdit itself. Okay, And now template title here. So it's a list with a counter, and here is a placeholder, filler long. So that's 4 bytes. Why is that in there? And then you have the item type and you have the item info, which is an OSTR. Trying to remember what OSTR was. I think it was a 0 terminated Pascal string or something like that. I don't remember what. Oh no, OSTR was, I think, an odd. I think it was an aligned string. I think you had ESTR for even aligned and OSTR for odd aligned or something, so that it would fit, because there's a byte here, a hexadecimal byte right before it. And so I think OSTR added a padding byte because it started at an odd address or something. That was, I think, what it was. Anyway, but so what is this filler long for? Well, easy. When you loaded this thing into RAM, you had a data structure, an array of items with a count at the start. And a long, 4 bytes, is exactly the size of a pointer. So what the dialog manager did when it loaded a dialog item list was it stuck the control handle, for example, for the push button, or some other data structure for the actual item that would be shown for this entry into this placeholder. So this is actually the identical data structure that you would have used on disk. That's just just some silly thing that you can see that so much of classic macOS was just having a data structure, writing it into a resource, getting it out of a resource, and just using it again. Which of course meant, like you could load stuff quickly because you didn't have to decode it in some way. And color icon was that big mystery for me for a long time because it didn't just do that. If you just loaded a color icon and passed it to some color icon drawing routines, it would crash in some very interesting ways. That is a surprisingly common technique on the old system. Speeds up and saves space by reusing the existing data and avoiding conversion, processing time, and memory requirements. Yeah, exactly. Because otherwise, every time you load a dialog, you load the resource and then all the memory for the in-memory representation, and only then can you unload the resource once you've read it. So, of course, it uses a lot less memory. Otherwise, you kind of like need the memory for your largest resource extra whenever you want to read a resource. Yeah, it's all clever and it all makes sense in context. It's just today one goes, well, we want to interchange between different platforms. In-memory data structures have a completely different layout. It totally, it would be silly to not have very different in-memory and RAM representations. Also, we're a lot more about speed and a lot less about memory, especially on systems with virtual memory like macOS and Windows. And so, yeah, it's just, it totally makes sense. And it's also like a programmer from today looking at this goes like, why did they do that? Like, it seems stupid from now on, but within these constraints, it's fine. It's just something you're taught not to do, basically. All right. I think I've pointed out everything I could have thought of regarding Myst and how it worked back then. So yeah, I don't know if anyone has some questions or requests of what we should look at, or if we should just call it a day. I mean, we're over 1.5 hours over now. Oh, 2.5 hours over. Goodness gracious. I'm gonna have to edit this. I can't, I don't think I can upload a 6-hour stream to YouTube. I mean, they'd let me, but no one would watch it. All right. Oh yeah, little tiny fun thing. Oh, similar thing is also done in resource maps. There's space in each resource for the resource handle, which is usually 0 in the resource fork, but is used when the resource map is in memory. Yes, right. Good thing. I'd completely forgotten about that. And here, I think the last classic macOS thing that I did on macOS 10 was a couple of years ago on a lark. I wrote code that can read and even to a degree write resource forks. Just because remember, I'm working on an HyperCard clone, or have been for way too long. And so one of the things that would be nice to do is, of course, to be able to import all those resources. And I have a converter of old HyperCard stack to a newer format that is then easy to read. And in that converter, before I had just used Apple's API to get the resources and read them. And I, progressively, I rewrote more and more of that code in my own rewrote more and more of that code in my own code, so that I wouldn't rely on Carbon APIs, which were going away. And that included writing code that can parse a resource fork, of course. And then I might as well try to write it. But I didn't stick too closely to, I think I basically generate my own data structure outside it. It's also funny how Resource Manager also compacts the resource fork on save. I think it's a bit smaller to the stack, similar to the stack compaction you demoed earlier today. Resource Manager basically moves modified new resources to end of file and only update rest file, close rest file, actual defrags the resource fork, writes the resource map at end, and truncates the fork length. Yeah, that's a classic thing for basically every block file format. I actually have a blog post on my website about how to write a block file format that kind of goes into all the different things you can do there. And one of the things and one of the things it goes into is just as an example, what a resource fork and also a HyperCard stack, which is kind of something resource fork-like, but simpler in the data fork. So how those work is basically just you put little blocks of data that you label with a type and a length and some other identifier like a name or an ID number after each other in a file, and then you can just skip ahead to one of those and read it out. Resource fork, of course, is very generic. It supports lots of types and things and has a table of contents. In HyperCard, it's basically just like you need to know the file format, and one of the blocks itself refers you to other blocks. And you just know these blocks have to be there, so you can just look for all the blocks and then get those. And then another block will just say, well, I need block 15 or whatever. And so that seems easy at first, but of course, if you have a format that you write to, and one block in the middle grows larger because, it contains the text of a text field, then you would have to move everything behind it down before you could make it larger. And that, if it's the first text field in a 4 megabyte file, that would be really slow on a floppy disk or whatever. Well, 4 megabyte floppy disks weren't a thing, but you know what I mean. And so what you instead did is you created a new block at the end of all the blocks and, wrote the same name and type and everything there, wrote the new longer data, and then marked the block at the top as free, which HyperCard did by just giving it the type FREE. Huh, clever. And then, so if you look in a HyperCard stack, like I'm not sure, I think we've fiddled with Myst, so we might be able to see a free block. I definitely remember pointing it out. I think we can search here, right? Yeah.
Uh-oh.
Okay, no, that was, I guess, when they did it for distribution. They probably deleted any free blocks. Here, our resources test stack, for example, has a free block in the stack and a background and a style table and a font table and a card, of course, and another free block. So that's what they basically did. And then compact stack. So either if you created a new block, it would see, oh, it's the same size. For example, if you delete a background, empty backgrounds are always the same size. So if you delete an empty background and then create a new background later, it will see, oh, there's a free block that's just the size of an empty background. I'll just put it in there and we'll reuse the free block. Otherwise, it will, just append it to the file. And then and then compact stack, that menu item that I use, basically just goes through, creates a new file, and writes all the resources that are not free into that new file. And so you get all these gaps taken up by free blocks deleted, and the file is small and there's no old data lying in it. This was actually documented in Inside Macintosh books, where they warn that modifying resources multiple times before update res file will incrementally take more and more disk space. I love those mechanics and data structures they invented back in the day, but that is super dangerous if system actually crashes during the compaction, as it would almost surely destroy the file. Yeah. I guess it depends on how they implemented it, yes. So there, for example, if you have, it could be really dangerous. For example, if you think, if you update it in place, if you compact a file in place, then you might have a real issue there. Because then you would have to, say you have a free block of 10 bytes, and after it a block of 20 bytes, and you just say, okay, I'll move it up. So the first 10 bytes, you can just write where the old block was. No harm, really. If it crashes there, as long as you set the length last, so the length is still correct, it would be fine. But as soon as you're starting to overwrite the first 10 of the block that you've just moved up, the first 10 bytes with its last 10 bytes, if it crashes somewhere during that, you've destroyed your header. And so that's why I'm not quite sure how HyperCard does it, actually. When you compact the stack, whether it does it in place. Like, more modern operating systems usually created a second file, compacted in there, and then swapped out the files. Or even in some more modern, in like even today, like in databases or something, there's a completely different approach, which I describe in my BlockFile blog post, where you basically always only write to copies, but maybe, you move some of the old stuff to the back and then mark the front as empty, so you have enough empty space at the front, and then you move it to the front, and then only stuff you don't want is at the end, and you can shorten the file, and it's gone. And then you have just like one spot where it says like what's the table of contents, and the old table of contents is past the end of the file, and the new table of contents is somewhere in the front where you keep it. And then you can just, these 4 bytes or 8 bytes, depending on what size it is, but like this number can just get swapped out with the new number. So it's like there are 4 bytes. If it crashes during writing those, your file is screwed. But otherwise, it's just either it's the old state or the new state, but it's always a valid file. It's really interesting to learn about this type of things about HyperCard. You know a lot about the system software works, but this is all totally new for me. If you see something, that's the bot. Okay. That's cool to hear. Yeah. I've spent like years and years, tinkering about with HyperCard and like deleting resources out of HyperCard to see how I could make it smaller until it would crash and things like that. Just to save space to get like Myst stack and HyperCard on the same disk or things like that, or make it look more like a real application. So yeah, that's fun. The weirdest part is HyperCard, like how it saves the graphics, which is it's basically row length encoding, but it has some tricks. Like it has basically operations for each line, and if you look at a typical, let's use this stack. So a typical HyperCard stack, like what is it? It's black and white graphics. So that could be all white, all black. That would have to... No, it's not pack bits, I think. It's something else. It's something Atkinson came up with for this. I don't think it might be similar to pack bits, because I think that might have been Atkinson as well. But here's the thing. You also have patterns, and a very common pattern on the Mac was this. I'm not sure if you can see this well on stream. This is a checkerboard pattern, so black and white. Wait, let me zoom in here. This is how it looks basically. And that's very, very common in black and white user interfaces of that era. So, how do you create something that encodes this efficiently? And I never quite understood how he does it, but I've helped a friend port code that decodes this format from Real Basic to C++. And so I've seen some parts of it, and how I've had it explained to me was that basically it thinks in rows, and it keeps track of the previous row or a few previous rows, something like that. And so when it decodes it, you might have one row that is black, white, black, white, black, white. And I think there might even have been like presets for like, this is a row with that is white, but with a black pixel every 5 pixels, or something like that. Or in this case, this is just a row that is alternating between black and white. And then they had operations to apply to that previous row and to use in drawing. So, for example, you would just this thing would probably compress into one black and white row. So it's just 512. So that's 256 black pixels and 256 white pixels that it compresses to. And then it says, okay, draw this row, then XOR it with a completely black row so that every pixel is flipped. Black pixels are white, white pixels are black, and draw that row again. Then again, XOR and draw, XOR and draw. And like I don't even know how you'd look at a graphic and say, okay, that's what it is. The previous line, like how do you even detect that the previous line is just an XOR of the current one? Like, did they do that check on every line because it was so common to have black and white patterns like that repeated this way? And I guess they, like, if you use this pattern, if you look at this, it's every second row is empty. So I guess that's also a common case, that you have two identical rows alternating. Something like that. But anyway, so they have an interesting way of compressing their graphics in HyperCard. Which means that, if you look at this stack, so we have a little script in it, and we have 512 by 342. So 512 there's 8 pixels in 1 byte. So that means 512 divided by 8, 64 bytes are needed to save one of these rows. And we have 342 rows, so that means this should be about 23 kilobytes, just for this black and white checkerboard pattern to save it uncompressed. I didn't compact the stack, but you see, it's 8 kilobytes. 9 on disk, and it will probably go down a little bit if I compact it, because remember, I think this is the stack we looked at earlier. Yeah, it's like 5.5 kilobytes, 5.6 if you round. And, usually would say, wait, the bitmap already needs 21. And it's one that doesn't compress with pure run length encoding. That actually, it's even this checkerboard pattern for pure run length encoding is the worst case. Like if you say, I save every pixel as, I save it as number and white or black. So like, let's say you have 7 bits for the length and 1 bit for whether it's black or white to save a bitmap, then you would use a byte for every pixel, whereas a completely black surface would just be 342 bytes, I guess, because an entire row, something like that. Hi Numnummers, how's it going? Oh, that's a cute lurk emote. Anyway, yeah, I think now I'm out of weird things to say about HyperCard, and I've long been out of things to say about Myst. Just sounds very cool. You think you're going to investigate this on the weekend. Always great to learn new stuff like this. Cool. Let me know if you find out anything about this graphics format, because I don't really understand it. I just repeating roughly, vaguely what they did back then. What I was told back a while ago. And I've seen a little bit in helping port this code that I mentioned, which is actually on my GitHub, if you're curious. It's the it's called Stack Export, I think. Anyway, you're good. Just on lunch. Okay, cool. Yeah, I think I'm about to wrap it up here. Wie geht's? Gut. Mir geht es sehr gut. Yeah, so, Tony, if you find out anything about that format, feel free to, I don't know, tweet, email, whatever at me. I'm very interested in this stuff. Particularly since the code that I have has a few bugs, which I just managed to defuse so it doesn't crash, but it doesn't quite correctly decode every image. So if someone could provide code that just extracts a HyperCard, stacks graphics into a modern format, that would be really useful. Or just, just make it a bitmap. Modern format, I can go from there. Or even better, write a compressor, then we can get going on writing original HyperCard stacks with something else. No, don't do that. That would be a waste of time, although it would be really awesome and cool. You will probably need a bit of digging, as HyperCard format is totally new for you, but gives an excuse to play around with HyperCard in the emulator. Yes. About that, maybe I should shamelessly advertise. Oops, who is following? Numnums is subscribed. Oh, thank you for the subscription, Numnums. I hope you'll enjoy having a cat with which you can wave. So for one thing, I run a little website that is called hypercard.org. Just trying to fit that into this little area for now. And among other things, what you can find on this website is, there's a link to the stack import tool I mentioned earlier. And there is 2 descriptions of the HyperCard file format. The first one is the one how I worked it out for my exporter. It doesn't contain the graphics format. It's just the general format, which is fairly easy. It's just block size, type, ID number, data, basically. But then I also describe a bunch of the parts. There's a lot of spots that say there be tigers, because I don't actually know what they contain, but it looks like these are mostly things, that were like caches or pointers used at runtime or things. But like this should get you where you can actually decode a HyperCard stacks format. The second one is with some corrections given by someone else that I haven't had the time to verify yet, or that I disagreed with, and I thought I'd put it here and we'll see, because there's some information. Also, I also have documentation for add color resources, which is how HyperCard stores the color information when you use the official extension that colorizes HyperCard. So if any of these things help you, Tony, then that's where you can find them. It's really good documentation. I hope, yeah. I mean, I needed to figure that stuff out, and I didn't want to forget it. So, yeah. Expecting less than good. Yeah. Oh, and just because I haven't shown that stuff, so I also have a website, orangejuiceliberationfront.com. That's my blog. And one of the things there is designing an atomic block file format, which is basically what I described a moment ago. It also has really nice graphics. Well, sort of. In the end here, it even describes like how you would do like an exchange and swap to write like the new stuff and the old stuff without it getting in the way of each other. So if you're curious about stuff like that, that's where you can find that. And with that, I think I'm calling it a day. The one thing I want to do is just see if there's someone online right now that would be appropriate. Usually I would just raid anyone, but no, I think I would have gone for either a science and technology or a music streamer, but there seems to be no one I know and trust on my list out there right now. Anyway, thank you for being here. Thank you for listening to me ramble on for hours and hours. And I hope it was in any way. By the way, do you have any background on why the HyperCard files end with Swedish sentence for "this is the end," or actually now it's over, to be more specific? If I remember correctly, someone told me that that's a phrase from a TV show or something like that. It reminds me, in Germany we had a Pink Panther show that kind of ended with him walking away and you seeing his tail waddle around behind him, and he said like some flowery goodbye phrase, and that's kind of always what I've remembered in my head, but it's from some Swedish TV show, and the reason why it is there is they needed some end indicator because this list doesn't have a counter. And I think they had just added, so that's the HyperCard 2.0 file format. And that's slightly different from the HyperCard 1.2.5 stack file format. And I think only the 2.0 stacks have, we can check because I have HyperCard 1.2.5 here. Not 1.2.5, but 1.2.5. Hex edit. Oh no, it's actually actually looks very different. Okay, I actually had never... No, it has a tail. But this one says, "That's all, folks." So I guess that's obviously, "That's all, folks" is Bugs Bunny. So maybe "Nu är det slut" was the... I hope I'm pronouncing this right. Please, anyone in chat who knows how to pronounce Swedish, tell me if I'm horribly butchering this. I'm probably getting the melody wrong. It's probably something like "Nu är det slut" or something like that, but I can't do Swedish. But anyway, so I guess that was just, they had this end indicator, it had a length, and then they went, well, we could do a 0 length block, but let's be funny and say, "That's all, folks." And HyperCard 2.0 added some internationalization support, I think, and that's why, as far as I remember hearing it, you get it in Swedish at the end. But I guess it doesn't matter because it only looks for, oh, it's tail, I'll bail. So these are just like extra bytes at the end. What I find a bit interesting is it seems like in the original HyperCard file format, there was no stack block, because this looks suspiciously like this file's, on OpenStack, so it's probably the stack script. And then we go MAST and list page. Yeah, so those blocks are all the same. Interesting. I might be able to actually read HyperCard 1 files if I can figure something more out about those. But 2.0 has the Swedish one, yes. You checked now that your version of HyperCard 1X has also English. That's all, folks, at the end. Yeah. Yeah, anyway, but that explains why HyperCard 1 files needed to be converted even more, because apparently they said, hey, we want to be able to... My guess is it was probably, like if you edit the stack script, then everything still has to move. So my guess is that's why they changed it to actually make the stack a regular block as well. Or is it just that the stack block has a 0? No. The length should be first, so unless there's a header, I don't know. Maybe I'll tinker a bit and find out. I don't know. But thank you for all being around, and hopefully see you some other time again. Maybe if there's another special, I'm doing something weird on the computer stream. I also have some art streams planned, especially... What was that? Something just went ding. Oh, I got a cheer of 100 bits. Thank you. I always take free money. Thank you. I don't know how I deserve all this, but okay. Anyway, yeah. I've been sitting for 6 hours, so I really gotta finish this now. Thank you for being there. Hopefully, keep an eye out on my Twitter or join the Discord and see there if there's any announcement about other streams that interest you. There will definitely be gaming streams every Sunday. Maybe there will be art streams, because now I've figured out how to get my drawing application on the iPad to not show nonsense on the capture card, but actually show the drawing. So, hey, technology. So I might be doing some drawing streams soon. I don't know, maybe I won't. It's always one of those, I want to draw more, and then I don't get around to it. And also there will probably be some programming streams occasionally, even if it's just me sitting there bored and coding on Stacksmith or something like that. My HyperCard clone-ish thing that I'm completely rewriting again. Thank you. Love you all. Bye-bye. Have a great rest of the week.